Hello, and welcome to the microwave engineering lecture titled Circuit Theory on Smith Charts. In this lecture, we're going to take a look into how we can add circuit elements using the Smith charts, like capacitors and inductors in parallel and series configurations, along with two examples. Now we will learn how to add a series capacitor using the Smith chart. Suppose we have an initial impedance on the Smith chart of Z equals 0.5 plus J 0.7, and we wish to add a series capacitor of normalized impedance of minus J1. This is where our initial impedance is located. When adding a capacitor, we do not change the resistance, so we walk towards capacitance counterclockwise around the constant resistance circle. This angular distance covers minus J1 along the constant resistance circle. And this is how you add a series capacitor. Now we wish to add a series inductor. Suppose we have an initial impedance of Z equals 0.8 minus J 1.0, and we want to add a series inductor of normalized impedance of J 1.8. This is our initial impedance. Since we do not change the resistance, we walk toward inductance clockwise around the constant resistance circle at an angular distance of J 1.8. This is how we add a series inductor. Now suppose we want to add a shunt capacitor. We have an initial admittance of Y equals 0.2 minus J 0.5. And we wish to add a shunt capacitor of normalized admittance J 0.8. Here is our initial admittance. Notice that we're using the admittance Smith chart, which is just a regular Smith chart rotated by 180 degrees. In terms of admittance, now capacitance is a positive quantity, so now we move downwards on the Smith chart. We move at an angular distance of J 0.8 and we arrive here. This is how we add a shunt capacitor. Now we will learn how to add a shunt inductor. Suppose we have an initial admittance of Y equals 0.7 plus J 0.5, and we want to add a shunt inductor of minus J 1.5. Here again, we use the Smith chart rotated 180 degrees to have it in terms of admittance. Now, in terms of admittance, the inductance is a negative quantity, but now the negative direction is upward on the Smith chart. So we move at an angular distance of minus J 1.5 and we arrive here. This is how we add a shunt inductor on the Smith chart. This is a summary on how to add different elements using the Smith chart. To add a series capacitor, we move counterclockwise on the impedance Smith chart. If we wish to add a series inductor, we move clockwise on the impedance Smith chart. For shunt elements, we use the admittance Smith chart, which is the Smith chart rotated 180 degrees. If we wish to add a shunt capacitor, we move clockwise. And if we want to add a shunt inductor, we move counterclockwise. Here is an example. Suppose that we have this circuit comprised of a resistor in series with an inductor, and both of these elements are in parallel with a capacitor. This is the frequency, and it's connected to a transmission line of this impedance. Now the question is, what is the input impedance looking into this direction? We can use regular circuit theory and do all these complicated calculations to arrive at the impedance, and then we can calculate the reflection coefficient and the VSWR. Now using the Smith chart, you're going to see that we don't require complex calculations and it is very easy. First, we normalized all impedances. This resistance normalized now has a value of 1. This inductor has a value of J1, And this capacitor has a value of 1 over J1.5 or minus J1.5. Now we will start plotting the load impedance. For this resistor, the impedance is located here. Now we add a series inductor, so we move clockwise over the resistance circles to this point. Now to add the shunt capacitor, we first need to convert to admittance. Remember that we first draw the visor circle from the origin to the impedance value, then we draw a line that crosses impedance and then intersects at the other side. This intersection is your admittance. Now from the admittance value, we add the shunt capacitance. So to add the shunt capacitance, we move upwards at an angular distance of J1.5 till this point. Now we can convert back to impedance. We draw the visor circle, we draw the line connecting the admittance and the origin crossing to the other side, and then we find the intersection. We know that this value is now 0.4 minus J0.8. So the input impedance is now this value. Now we denormalize the impedance to find the real value of the input impedance. This is how it looks putting all the steps together. First we start with the resistor, then we add the series inductor. To add the shunt capacitor, we convert it to admittance, and then we moved along the admittance circles. To get the input impedance, we convert to impedance back again, and we arrive at the final value. Now for this example, we will use the combined impedance and admittance Smith chart. We wish to know what is impedance looking into this normalized network. Now you will find that using the combined impedance and admittance Smith chart makes it even easier to add many circuit elements. First, we can add this resistor and inductor in series and then plot its value on the impedance. Now to add the shunt inductor, we move along the admittance circles to a value of minus J0.3. We arrive at this point, and this is impedance. Now we add a series capacitor. So we move along the impedance circles downwards at a distance of minus J1.4, and we arrive here. Now to add the shunt capacitor, we move along the admittance circles a distance of J1.1. Now finally, we add the series inductors. So we move along the impedance circles now in a clockwise manner, and we arrive at our final point. The impedance here is equal to 0.2 plus J0.5. Now if we read the admittance, we will arrive at this value. Notice how easy it was to navigate the Smith chart to add many circuit elements in series and parallel configurations.